Welcome to queenon7.com. Please do share and like my videos and put the comments if you want me to upload any video. We're going to look at the one of the substituent of benzene, which is called phenol. Whenever the OH group is connected with the benzene ring, it will be known as phenol. If a benzene ring is attached, just for example, if you have benzene ring, it is attached with the carbon and then you have OH group, that will be known as an alcohol, not as a phenol. So the basic requirement is the OH group should be directly attached with the benzene ring. It is then you can actually categorize it as the phenol. We're going to look at the three reactions of phenol, and the last one I will explain the effect, the directing effect of the existing group on the benzene ring. Now the properties of benzene, phenol has OH group on the benzene ring. The OH has oxygen. That electron pair is actually delocalized inside the benzene ring. That means that the electron density has gone inside the benzene ring. The electron density will increase inside the benzene. So that will actually make it very easy for phenol to lose the H positive ion. So phenols are considered as weak acids. So the hydrochloric acid or the very famous acids like H2SO4 or nitric acid, they all are strong acids. And carboxylic acids, they are weak acids. Phenol is actually weaker than the carboxylic acid, even weaker. So the H positive ion will be released, but it will not gonna make carbon dioxide like every other acid. When they react with the carbonates, they produce carbon dioxide. They're not strong enough to liberate carbon dioxide from the carbonate. So it will undergo only, if this is the phenol, you're going to react with the sodium oxide. It will make sodium phenoxide O and a positive ion, and then you have H2. The hydrogen gas will be produced. Also, you can have benzene ring again with the OH group is the phenol. You're going to react with the sodium hydroxide. Sodium hydroxide will produce the same ionic product, and it will make water now. So acids and bases, they react together to go under neutralization reaction and produce this. Phenol is can produce all these two reactions, but they cannot actually produce the carbon dioxide with carbonates. In the previous video, if you do remember, I explained the bromine can react, or chlorine can react with the benzene only when you have AlCl3 or FeBr3. So they do need some sort of support to actually produce an electrophile which can actually attack with the benzene ring. Now, if you look at in this reaction, the phenols do not require AlCl3 or FeBr3. The reaction will happen at the room temperature and it will produce a bromine phenol. The reaction won't stop and the reaction will carry on, and further substitution will happen and it will make 2,4,6 tribromophenol. The reason behind this, why the bromine is actually reacting with phenol at room temperature, is because of the oxygen in the OH is actually pushing the electron density inside the benzene ring, making it more negative in terms of electrons. So more electron density will be provided inside the benzene ring, and that benzene ring will actually polarize the bromine molecule itself. And when the bromine molecule will come close to which is actually a neutral molecule, but when it comes close to the benzene ring, that electron density, which is actually increased by having the oxygen inside, the delocalized electron of the oxygen inside the benzene ring, that will actually make it polarize and will produce Br positive ion, and that will attack straight away onto the phenol and produce the 2,4,6 tribromophenol. And this is one of the very best method to produce the 2,4-trinitrotoluene. Now, directing effect, there will be a very good video I'm going to upload which will have the detailed explanation of how the positive charges actually move around and delocalize inside the benzene ring, and will have an explanation why the benzene actually have this sort of directing effect when it already has an existing substituent. Now, if this is a benzene ring and you have a molecule already existing on the benzene ring, and there's another benzene ring which has got OH and it's a phenol. Both of them will have a different effect on the oncoming molecule. So for example, if I have bromine coming in and going to react with both of these molecules, nitrogen is more electronegative than the carbon, but nitrogen does have an electron pair there, and also as oxygen. This nitrogen is actually attached with the oxygen, which is more electronegative than the nitrogen, and because of that, the electron density will move more towards oxygen. So the nitrogen will feel a little bit electron deficient, so it will take some electron density out of the benzene ring, so it will deactivate it. And in the next video I will explain on what position it is going to deactivate the positive charge. Once it's going to take it out, there will be only few positions available for the attacking electrophile, because this is going to be an electrophile anyway, otherwise it cannot actually react with the benzene ring. To do this, the shortcut to remember is, if the existing group is actually taking the electron density out of the benzene ring, the oncoming molecule will attach itself on the meta position. Meta position, or you can say number 3. So benzene has got 3 positions. If you have an existing group, call it as X. So this one is 2, 4, 6 position. This one is 3, and this is 3 as well. Or you can call this one as well 2 as well if you want, but 2 or 6. So the oncoming molecule can only come on this side, because the electron, for the positive charge, the moment it is going to take the electron density out of it, the positive charge will be delocalized on these positions. So the oncoming electrophile, which is already Br positive ion, cannot actually attach on these positions. So the bromine positive ion can only go onto those positions where there is no positive charge, because the same charges will oppose each other. Same goes for this, but the position will be different in this one. Electrophile will be produced Br positive, but the oxygen is actually connected directly to the benzene ring, but the hydrogen is less electronegative than the oxygen. So the hydrogen is not pulling the electron density away from the oxygen, so the electron density will actually go back inside the benzene ring, and the electrons will be delocalized. In that case, the bromine, when it's going to come, I can actually write down that because of the electron density which is increased, the benzene ring will have the positive charge appears on these 2 positions. So the oncoming molecule, ion, whichever it is, for example, be a positive ion, it can go either at 2, 4 or 6 position. In chemistry, we call it as the adjacent position to the existing group is called ortho. So this one also be called as ortho, and this one is called para, because it's parallel in front to the existing group. So this is how the oncoming group will be attacking on the benzene ring. So please wait for my next video, which will help you to understand the directing effect because of the existing group on the benzene ring. Thank you very much.